This is Kanessa Io, and today I will bring you Lecture 4 on Malthusian economics. In Lecture 3, we asked the question as to why income stagnated for that long period in the hockey stick graph. We'll use the Irish potato famine as a starting example to sort of explain the economic intuition during this time period. In 1845, they saw the devastation of the crop. This led to about 1 million people dying. There were people from around the world, from Western Europe to Bengal, who were offering donations to alleviate the devastation of this famine. At the time, however, many economists were welcoming a famine of this scale. Nassau Sr. famously stated that the famine would scarcely be enough to do much good. Now, Sr.'s comments are morally objectionable in this case. However, they're rooted in Thomas Malthus' intuition for the current or during this time period. Thomas Malthus is a famous economist who earned the reputation for economics as being the dismal science. We can see in the figure on the right that the left-hand axis is covering real wages and the right-hand axis is covering population. And we see this period from 1300 to 1600 covering the orange line that's referred to as the Malthusian Trap. And we can see this process as sort of being cyclical here. We see a rise in wages that's sort of matched with a rise in population, and the decline in wages also results in a decline in the population. And Malthus saw this cyclical process over this time period, and so you can see how Senior is trying to sort of build on that intuition with the famine, basically stating that it's a necessary process in order to alleviate these rise in wages. Today, as we discuss the Malthusian model, we'll focus on two key assumptions. The first being that the production function has a diminishing average product of labor. So first, we need to define an average product. Our average product is our total product divided by the number of farmers. And so we'll utilize production functions to calculate our total product and then divide that by our inputs. The second assumption is that population increases when the average product exceeds subsistence. And we'll get into this in a little more detail, but in this case, subsistence being our minimum required for survival. And so what we're saying here is that as productivity increases, there will also necessarily be an increase in the population. In order to analyze the Malthusian model, we need to first begin with production functions. These can be expressed in three different ways. The first being an equation. We have y equals f of x, where y is a function of x. In this case, think about y as our output, and our f of x here is our input. So maybe we input laborers, and as a result, we receive some sort of wheat or grain. Secondly, we can express the same thing as a table. In our case, we can see an input of 200 laborers would result in 200,000 kilograms of grain. And lastly, we can illustrate this as a figure. So walk through these and sort of figure out which one is most comfortable for you, and try and practice your homework with each of these three examples. In this lecture, we'll analyze these production functions graphically. So let's begin by picking a starting point with 800 farmers. At 800 farmers, so this being our x-axis, you can see coming down from our production function at point A, we have 800 farmers as our input. We input them into the production function, and as a result, we get 500,000 kilograms of grain produced. Now, let us calculate our average product in this case. For our average product, we take our total product and divide it by our inputs. So in this case, our inputs are the number of farmers, and our total product is the amount of grain produced. So at point A, we have 500,000 kilograms of grain. We divide that by how many laborers we used, and we get 625 kilograms as our average product. Looking at a second example with 1,600 farmers, at point B, we can see that our total product is 732,000 kilograms. Now calculating our average product, we simply take our total product, the 732 kilograms produced, and divide that by how many farmers we input into the production function. And we get 458 kilograms of grain. Now, something to note with our graph is that when we started with 800 farmers, we had a smaller total product. And then when 1,600 farmers were introduced, we increased our total product. However, the movement from 800 farmers to 1,600 farmers decreased our average product, which fell from 625 kilograms to 458 kilograms of grain. This implies that we have a concave production function, or that the production function in this case has a diminishing average product of labor. And so this is one of our assumptions that we discussed in an earlier slide, and it's important to keep in mind as we move forward. Now we must discuss, why does the average product diminish? The first reasoning is that we have a fixed quantity of any resource. So resources are scarce. This is one of our fundamental principles in economics. And so we're devoting more and more labor, more and more machinery, whatever the input is, to a fixed quantity of something. Thinking about this and bringing a little more context to it, think about the state of Colorado. If we were to bring the entirety of Colorado into cultivation, we would see that we would be bringing inferior land into the process. So you see on eastern Colorado, we have much of the plains, and you can see a lot of agricultural processes being run in this area. And as we move west, it's very difficult to grow a lot of different things as we move to higher and higher elevations. And so therefore, that's not very suitable land for that type of production process. And so we would see the average product diminish. Thomas Malthus saw an inverse relationship between the average product and population. So as we saw an increase in the population, we would see a decline in the average product. He also argued that the population increases when the average product exceeds subsistence. You can take a look at his quote here, but essentially his statement is saying that once individuals have anything above their survival needs, they will begin to sort of increase the population from there. So now you can think of the process of, you have all your food, your water, and your shelter, and you have a little extra income above that. And so now you may feel the need, or you may feel it's okay to have more children and so forth, and this would increase the population. He also believed that technological improvements temporarily increase the average product, but this eventually increases the population until the average product falls back. And so what we discussed in lecture 3, dealing with the permanent technological revolution, this is something that Thomas Malthus was unable to foresee during his analysis. He believed this was more of a cyclical process. You'd see improvements in technology. This improvement in technology would increase the population, and that population would actually drive the average product down back to subsistence levels. Now let's take a look at Thomas Malthus' intuition graphically. We'll start by assuming that peasants need 458 kilograms to survive. At this point, our equilibrium is B. At B, we have 1,600 workers being put into the production function, and the output being the 732,000 that we saw in the previous slide. At this point, we are exactly at subsistence level, so the average product is 458. Then we have an increase in productivity. This increase in productivity will shift our production function upwards. In this case, our new equilibrium would be point C. At point C, our total product is 840,000. So given that we have the same number of inputs, so we're still at 1,600 farmers being put into the production function, we'll see that we have an increase in our average product. So we've moved from subsistence level at 458 kilograms to 525 with the movement from B to C. However, remember that Thomas Malthus saw that this increase in the average product was only temporary as a result of productivity increases. Therefore, we have a new equilibrium point that would be our long-run equilibrium at point D. At point D, our total product is 916,000 kilograms. Now that we've had this increase in productivity, we've had the increase in the average product, this is only temporary as we have a population increase and therefore more laborers are now entering into the market. So now we have an increase in our total product of 916,000, but we also have an increase in the number of inputs. So we have 2,000 workers now in the production function. So we take 916,000, divide that by 2,000, and we get 458, meaning that we have moved back to our subsistence level average product. So in this Malthusian trap, technological progress increases population, not income, which is something that we can juxtapose with Lecture 3, where we discuss that permanent technological revolution. So just walking back through our slide real quick, we start at point B, we see a productivity increase. This moves us to point C. However, this is only temporary for the increase in the average product, as we now have a larger population moving into the labor market, which pushes us to our long-run equilibrium of D and puts us back at our subsistence level average product. Now that we've looked at Thomas Malthus' model graphically, let's illustrate it more in a conceptual model to sort of drive home the intuition. So we have this improvement in technology. This was our movement from B to C in this case. Remember, our average output per farmer rose. This leads to an increase in the farmer's income. However, this rise is only temporary because it's accompanied by a population increase. As the population increases, we see less and less land per farmer, and our average output falls back to our subsistence level. And so as we move from left to right in our flow chart here, we can see the movement from point C to point D in our previous slide. And this is what we refer to as Malthus' law, or the iron law of wages. Now it's important to ask the question, is the Malthusian model a good model? According to our volunteers at Wikipedia, we saw that the Black Death caused by the bubonic plague killed about 40 to 60% of the population in Britain in a short 1-year period. And it killed 20% of the population in a subsequent period. This result, we saw a huge decrease or a huge decline in the population, so this caused a shortage of labor and a rise in wages, and eventually contributed to the Peasants' Revolt of 1381, and this led to the abolition of serfdom, in which serfs basically toiled over the land in order to pay rent to different lords. And we can illustrate this graphically. I would encourage you to look into your textbook. They have a wonderful example where they zoom in on this Malthusian trap. We can take a look a little further into assessing the validity of the Malthusian model, whether it's good or not, with our two graphs here. The first one being the same one that we've analyzed in previous slides. Our second graph here helps to tell the story a little clearer. We have our y-axis here illustrating the real wage, while our x-axis illustrates the population. And we can see there is a black circle, a black point, that's illustrating the 1340s and the 1600s. And if we trace the graph, if you move leftward following the arrows, you can see that the Malthusian model is doing an excellent job of illustrating this process of a rise in wages constantly followed by an increase in population and so forth, and then the subsequent result that we've covered in the previous slides. And now this graph sort of ties Lecture 3 and Lecture 4 together. So we saw the last graph illustrating that cyclical process, we saw it in the production function and so forth. And in this graph we can see this blue line to the right that illustrates the escape following the 1800s. And so this escape deals with what we talked about in lecture 3 as the permanent technological revolution. So Thomas Malthus was never able to foresee this process in which technology would permanently increase individuals' income without this massive increase in population. And so we can see through our graph, sort of analyzing different points, that Britain was stuck in this trap for basically 3 to 4 centuries, and then again from 1740 to the 1800s, right before the Industrial Revolution. And then following the Industrial Revolution, we finally see Britain escape from the Malthusian Trap. And at this point, we see the permanent technological revolution kick in. We saw total product growing faster than the total product growing at a faster rate than the population increase. We saw improvements in healthcare and so forth, and so these alleviated deaths in a lot of different areas. We saw the average life expectancy increase. And we see other things like contraception and family planning, especially moving into the 20th century. This is also accompanied by other things many of you are experiencing with rises in education costs and so forth. So now you have to plan a lot more carefully before bringing children into the world. And then lastly, we'll illustrate this sort of permanent technological revolution following from the Malthusian Trap all the way to a more contemporary time period. We can see this graph illustrating a couple different things, this divergence in productivity and wages. So in this case, our orange line following the bottom of our graph here illustrates real wages, while our blue line illustrates labor productivity. And so we've seen this permanent technological revolution cause a massive increase and a permanent increase in productivity over this period, while we've seen a very steady, slight increase, and at some points actually a decrease in real wages. It's important to note a couple things. What do our wages depend on? The first being the average product of labor. And so this is something that we've really focused on throughout this lecture, taking our total product that we calculate from our production function and dividing that by the number of inputs. The second thing is the worker's bargaining power. We'll discuss this in units 5 and 6 in much greater detail, but a worker's bargaining power deals with their reservation options. And so what does somebody have to fall back on? If somebody has very little to fall back on, then they have very little bargaining power. However, the more and more that you have to fall back on, whether that be inherited wealth or different job prospects and so forth, this increases your bargaining power. And so these will be two huge determinants in wages.